Hi and welcome to my channel Math with Amina. We have our next question which asks us to express the given numbers as product of prime factors in the index notation. To do this, we need to break each number down into its prime factors. In the previous exercises, we have already practiced expressing numbers as product of prime factors using different methods that includes the tree diagram method, which I also have utilized in this question. The other method is the division method. You can practice any of those methods in order to express the given numbers as product of prime factors. Once we have the prime factors, we look for that numbers, or we look for the factors that are repeated. And once those numbers are identified, or those factors are identified, instead of writing the same prime number several times, we need to use index notation to write them in a shorter form. So taking a start with the very first number, that is 64, it is expressed as a product of prime factor using the tree diagram, as you can see. So these are the products of the prime factors. In here, as you can see, the prime numbers are encircled. If you remember, we had defined a prime factor to be a number that is greater than 1, that is exactly two factors, 1 and itself. So those prime factors, they are encircled. Now we have to see how many times each is in here expressed. So we can see this 2 is expressed in here 6 times. So if we express the product of this, the product of the prime factors for this number in index notation, so the number that is appearing repeatedly, it is 2, and the number of times it is repeating, it is 6. So the index becomes 6 and the base becomes 6. Then we come to the next number, we have 243. We express this number as product of prime factors using the tree diagram. Then we encircle the prime numbers, which is 3 in here. We encircle them. Once we have the prime factors, we see for the number of times it is repeated. So this 3 being the prime number, it is 5 times repeated. So the base will be the 3. It is the number that is getting multiplied, and the index would be 5 because it is appearing in multiplication 5 times. Then we have 400. So 400, again using the tree diagram, it is expressed as product of prime factors. So it is 2 multiplied by 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 5, and then multiplied by 5. So once the number is expressed as product of prime factors, those factors, then we'll look at those prime factors and see how many times those numbers appears in the multiplication. So if we see we are having two prime numbers, that is 2 and 5, then we count how many times each is expressed. So 2 is 1, 2, 3, 4 times appearing in multiplication. So it would be base of 2 and index of 4. The 5 prime number, it is the base would become 5 and the index would become 2 because it appears twice in multiplication. Then we have 1600. So 1600, it is expressed as a product of prime numbers, prime factors. After that, we look for the prime factors. In here, those prime factors are encircled in purple. So we see if it is one prime number or more than one prime number. If we see we are having two prime numbers, 2 and 5. So the base would be 2 and 5, 2 multiplied by 5. Then we, for each, see how many times each number, each prime factor appears in multiplication. So 2 appears 1, 2, 3, 4, 5, 6 times. So the index of 2 would be 6. And then we look for 5, and so 5 appears twice in multiplication. So it would be 5 raised to the power of 2. Then we have the next question. 16384, we express this number as product of prime factors, as you can see using the tree diagram method. Once we have expressed a number as product of prime factors, we look into the prime factors of it, as these are encircled in this diagram. Then we identify the numbers, what different numbers. In here there is only one prime numbers, that is in repeated multiplication, and that number is 2. So the base would become 2. Now we see how many times this prime factor of 2 is repeated in the multiplication. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this appears 14 times, therefore the index value would be 14. So writing this number as product of prime factor in index notation, it would be 2 raised to the power of 14. Then we have our next number, 2736. So it is 20,736. Again, we use a tree diagram in order to express it as product of prime number factors. Once the number is expressed as product of prime factors, we look into the prime factors of it and see which numbers are included in the prime factors, and they are in repeated multiplication. So there are 2 prime factors, 2 and 3. So this would be serving us in the index notation as the basis. So it would be 2 multiplied by 3. Then each number, in order to find the index value, we will see how many times each number appears in multiplication. So 2 appears 1, 2, 3, 4, 5, 6, 7, 8. 2 appears 8 times, so the index value for the base 2 will be 8. Multiplied by 3, and then we count 3, 1, 2, 3, 4. So the index value for base 3 would be 4. This way we were able to express this number 20,736 in index notation by utilizing the product of prime factor method. Then we have 59,049. Yes, so now in order to write it in the index notation, we have to express it as a product of prime factors. I have utilized the tree diagram. Once the number is expressed as product of prime factors, then we identify the prime numbers in the prime factors. Then we see in here it is number 3. It is the 3 prime number, which is in repeated multiplication appearing. Once we know which number it is, that serves as the base in the index notation. After that, then we count the number of times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 appears in multiplication 10 times. So the index value would be 10. So we have expressed this number in index notation using product of prime factors in this question. Then the last part, we have different questions. Yeah, I think we have covered all of it. Just the last part is remaining. 3,90,625. So this number, we expressed it as a product of prime numbers or prime factors. Then using the tree diagram, then we identify the prime numbers. Once the prime numbers are identified, then we see how many times these repeated prime numbers appears in multiplication. So 5 appears, since we know it is 5, so 5 will be written as this, as the base value. Then we see or count the number of times it appears in multiplication. So 1, 2, 3, 4, 5, 6, 7, 8. So 5 appears 8 times in multiplication. Therefore the index value would be 8. So we were able to express the following as product of prime factors in the index notation. That was all for this question. I hope it's all clear. You have to keep in mind that when we are expressing a number as product of prime factors, there are two methods. You can watch the previous exercises which we have practiced the different methods, the division method and the T-diagram method, and the previous questions in which we have practiced the index notation. First thing that needs to be remembered when solving such questions is that first the prime number, first we find the prime factors, then group the repeated prime factors and use the indices or exponent to write them in shorter form. So